Hello all, in this video I'm going to be going over how to make a basic moving character using a rigidbody as a base. So here's the project and I'll show here's the finished example, the little guy. It's just got a basic animation that blends from a static pose to just a simple walk animation, jump that has a loop while it's in the air. And yeah, I can just jump up with these. Here's the basic scene that we're going to actually make our first situation of the player character. I've got a basic capsule here for now that has a rigid body that I've set, frozen the rotations, made sure gravity's on, set the drag value to 3 for now so it's set to something, and added a script just called player script, nothing on it yet, that we're going to give the basics to. So let's go into the scripting editor. And what we're going to do now is we're just going to add very basic controls of I press down, up arrow, down arrow, left, right, and it will move left, right, up, down. And with the script I've done, there'll be a slight, we're adding in an artificial kind of drag to that, but we'll look at that when it's actually in. So first thing, add the basic settings we want. So they're the variables that you can set to change the speeds and the like. Variable to store the movement. We actually calculate from our inputs and make it work. And the rigidbody, since we're using the rigidbody to move, we need to actually be able to reference in our code. And if I just put this line here at the start, this just gets the rigidbody from the object that the script is on. So first thing in the code is this here. This just gets the inputs from the up and down arrows. That's the horizontal and vertical inputs, left and right. Just those inputs, or joystick, depending on how it's set up in the inspector, which we'll be using to get our movement inputs from. And then for now, we'll just assign them directly to movement. And since we're using rigidbody and forces, while we calculate the inputs in update, you usually always want to actually want to implement the movement inside a fixed update for physics things. So while update is every visual frame, fixed update is every physics frame. It's a bit, so you won't notice it, but it's kind of calculated a bit slower because it would be expensive doing it every single frame, but it works out. And for now, literally all we need is to just get the rigidbody, type this in manually, move position, which is the method of movement we're using for this example. We're just going to put the transform.position, then we're going to add, in brackets here, movement times move speed times time dot delta time. And just to explain what all this here is doing is move position is one of the methods of moving an object that's a rigidbody. Essentially, if you put in a coordinate, it will go from where it is to that coordinate if it's feasible, so kind of make a direct path towards that. So if there's a wall in the way, move position won't let objects go through walls, but it will attempt to move in that direction. So what we're essentially doing is transform to positions, that's where it is now, and we're adding onto that the direction of our inputs, that's movement, multiplied by the speed we want to assign our movement, and then while it's multiplied, it's technically divided by time.delta time. That makes the movement sort of makes it fit within a frame rate. So it means if this was running on 50 frames per second, 10 frames per second, 100 frames per second, it should still, over the same amount of seconds and times, do the same amount of movement. So you're going to have something on a high frame rate moving super fast compared to something on a slow frame rate. So we actually go into our scene, and there's no errors. We should see, there we go, there's our basic settings, and if I click play, there we go. So we've got the very basics of the input, and actually while we're here, I'm going to move the camera. If you select your camera. If you just go into game objects, align with view, there you go, get a bit more of a dramatic perspective, which is nice for viewing things on. And I'm using a joystick for this purpose, using the arrow keys. You can also use them too. What you'll see is I'm moving forward, down, right, left at the moment. And while that's good and all, in the controller we have, if I actually add, I've got a visual aid for this, so I'll just add that in. My prefabs, GUI. Here you go, so this will show you what I'm actually doing with the joystick and inputs. You can see that while I'm moving forward, back, right, left, the character isn't moving kind of in the same coordinates relevant to what I'm actually doing. It's just moving the global forward, global back, global right, left. So we're going to add in an extra function in the code that's going to convert the inputs to the direction the camera's facing, so that when I move forward with the joystick, it'll actually go kind of more diagonally, because that's where the camera's looking at it from. So let's do that now. So I'm going to do this as a function. I'm just going to copy and paste the whole function in, and then I'll explain how it works. And I need to add a reference to the camera. Here we go. And let me just actually do the full thing. So if I go align, and I need to actually, if I do, I'll leave this as is, but there will be an error from this, and I'll explain what that is when it pops up. But anyway, so what this is doing here is we are putting our inputs, that's the vector input direction there, we're putting it into this function, and what it does is it gets the forward, if you know what forward directions are. So when each object has a local forward, right, and up, we're getting the forward of the object we're referencing, in this case the camera. We are then zeroing out its y-axis so that it's flattened to the ground, because if the camera's tilting down, we don't want our inputs to be pointing downwards, we want them to be pointing flat on the ground. And then we are setting, so by doing this here, we offset our inputs we give it by the direction of the camera, and we do that by turning the camera's forward direction, which was a vector, into a rotation. That's a quaternion with this. Quaternion look rotation turns vectors into a rotation facing the same way. And when you multiply a rotation by a vector, it offsets that vector. So it's a bit hard to kind of explain without you seeing it. So, and if I go into the script, you'll see that there's an error. If I go here, I know what it is, so I can actually just fix it immediately. You see I put ref here, and I just need to put ref there. Usually when you put a value into a function like this, it can't actually change that value unless you put ref there, which actually means it explicitly knows, okay, whatever changes I do within here need to apply to the actual thing. So now let's go back into Unity, errors all gone, and now I like this door, and oh, I need to actually set the reference player. So if I just go there, I get camera main and drag it into here. Alright, there we go. So now you can see the direction the joystick's going, and if I make it more drastic with the camera, there we go. So I'm going forward, back, right, left, and it's appropriate to where the camera's facing. So that's just a bit of polish that for this kind of movement you need. So there we go. Okay, so that's the very basics of the movement. The next two things I'm going to do now is just kind of run through adding rotation and vertical motion, which I'll run through and then I'll explain how they work. So I'll edit back once I've actually added it to the script, and then I'll go through how it works. Okay, so here's the additional bits of code, and I'll just go through what's happening here. So I have added this vector here just to copy the movement. So because fix update, so a slightly different frame rate from the inputs. I don't want to change the inputs while in this, so it's just kind of copied it into this value called final movement just for here. And the first thing we do is file movement. So if there is an input of anything pretty much above 0.5, so that's just essentially if the players actually inputted something for movement, buffer to get a new rotation, and here we're using, if you know what, this is basically the same as vertex lerp and slurp, so it's just getting, in this case, 2 rotations, and then by the so here's one rotation, here's the other one, and by the number you've got here, it just goes somewhere between those 2 points. So that's our rotation speed multiplied by time dot at time to keep it consistent with frame rates. Stored rotation is a value I put up here, and I set at the very beginning. That just keeps track of what the rotation is, even when there's no inputs. And look rotation is, again, that's just turning the direction that the inputs are after they've been converted to face towards the camera as a rotation. So after that, we immediately set the rotation to look in the direction that we're moving to with move rotation stored what. We do the rotations before the other things here because in the next few steps we're going to be adding vertical motion to the movement variable. And if we did rotation after that, then we'd have the character pointing at the ground and pointing at the air, and we want them to stay upright. So in this next bit, because we're using move position, the way to use move position is most people have a value that keeps track of vertical motion. So they actually add in gravity in the script rather than using rigidbody's gravity. And in order to jump, they add to the kind of vertical speed. So what we've got here is this highlighted area here handles the gravity and handles jumping. So we've got if raycast, and we've offset the way, actually for this one we don't need to do that, it'll come up later, but we have our raycast that's pointing down at a maximum length of 1.1, so that's a little bit more than the height of the player, which we want, so there's a little bit of leeway. If it hits something on the ground, then the character is grounded, set vertical speed to 0, and also allow the player, if the jump button is pressed, to jump, and we do that by just immediately applying whatever our jump force value is to the vertical speed, and that's handling jumping and if the character's grounded. And then every single frame we've got this here that continuously adds gravity to the player character. So if you're in the air, that will gradually get higher and higher until it reaches the gravity value. Or if it's on the ground, it just adds a tiny bit of gravity to make sure that they're still somewhat going downward. Next line of code just make sure that if you are in the air and you kept falling, this value up here didn't keep adding more and more gravity on, so it just clamps it to whatever the gravity maximum value is and clamps the height to whatever the jump value is, so you're not going to have your character go flying 50 miles per hour into the air or falling 50 miles per hour to the ground. And then at the very end we add this to the Y value of the input, which until this point has been 0. So when we get to move position, it is added along with everything else to the player. So if we go into our scene now with our little basic fella. Oh, I accidentally was messing around with these inputs between edits, and we go jump force back down to 3. There we go. So he's got a nice low level jump, and he now, when you face a direction, he slowly, and that's why I did the vector slurp thing. I will maximize this if I go here. If I reduce this rotation speed, you see they take a while longer to rotate. Still move the same. Rotation's kind of more decorative for this version of movement. But anyway, so we can set the rotation to look towards things. You can jump, and we can change that value. We can change the running value and all that stuff. So yeah. So with this, you've essentially got the basic version of your character as you'd want him, just to test out and prototype things. So the next step would be to actually add animation into this guy. So now I've got the basic character working, I'll go over the next step of actually animating him in the next video. So that's all for now.
Mm-hmm.